All right, so I will start by creating a new part. Okay, and then I make sure that enable hybrid design is not clicked in. I'll just go ahead and give it the name here. I will call it fuselage. Fuselage. So one important thing to remember is that I am doing this the way I think is appropriate. It doesn't necessarily mean that it is the appropriate way of modeling. Create a geometric set. I'll begin by putting a point on 0, 0, 0. Rename that point to point start. And then I will create another point based on the first point, and then I'll move this point to, let's say that we have an aircraft which is 20 meters long, maybe some kind of a business jet. There we go. Then just press the yellow button here to move out. So if now I have my points here, then I can create a line between these 2 points like such. Press OK. If I press with the middle button here, then my rotation point, and just press and release, and my rotation point will become in the middle here. And now if I press middle button and the right button on the mouse, then I can rotate my model. If I release the right button, I can zoom in and zoom out. Usually this is something which we show you during the lab sessions. It's not that difficult, but it's difficult to explain over a video. There are a lot of helps on the net if you search how to navigate with the mouse in CATIA V5. So now what I will do is that I still simply will take another point, and then I will put it on this line. Immediately I will get on curve. I will put a ratio of length here instead of absolute length. So now it's 17%. I will make it 20, maybe 30%. And then I want it to start from point start. Also I want to change this point name to point end. And then this will be wing position. Like such. And then I will do another point. It will start point start, and then it will go to, this is for the horizontal tail. Let's say it goes to 80%. There we go. We call this horizontal tail position. And then I will create yet another point again on the curve, but I will choose the end point, and I will have to reverse and choose maybe 0.2. Yeah, something like that. So it gets this for just to so they're not colliding. Here's the for the vertical tail position. Tail position, like such. And then I want to create yet another point for the engine from point start. Let's say that this one goes to 0.7 or something. There we go. So when it comes to the engine and the horizontal tail, they will necessarily not have a component connected to them. So it's a possible position. It depends on how the user wants to configure the aircraft, but that will become clear later on. Okay, so now I have my most important geometries, I would say. We're up in 1, 2, 3, 4, 5, 6, 7. I want to say that another important point is, let's say, coordinates here, and then we'll take that point 0, and then I want to say that this becomes the nose tip position, and let's say that it goes down 500 centimeters down, minus 500 centimeters. Nose tip, and then let's say that we have some kind of a position for the end of the cockpit. So this 0.1 is good enough, and then from point start, cabin end, like that. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. Then we can have 1 point for the end of the aircraft as well. Coordinates from this point, and let's say, for the sake of it, this one goes up 500. Something like that. So tail end. Okay. Now I have my 10 first geometries. I would say that these are the most important from my perspective, and as I have mentioned before, there are many right ways of doing this. I would argue that this is one of them, and I think this solution is a good solution, because now if I start changing the point end to say 15 meters instead, then all my points will follow accordingly. So this is a robust way of building my skeleton motor for my fuselage. Okay, so now we have built the main points, and now I would say it's time to start filling in some more geometries in order for us to be able to connect other parts through instantiation to this fuselage.